Okay, guys, so we're back to vlog number 2, and what we're going to do this time is we're going to learn how to actually program this chip that is on our board. Okay, so last time we actually kind of cheated because if you recall, we took power using these jumpers straight from the 5-volt and ground like this. Okay, and that's fine because 5-volt and ground are always present on these ports. But what we want to do is we actually want to feed our LED not from an always on 5-volt port, which is what this is. Okay. What we want to do is we actually want to take 5 volts from a pin that we can control between high and low. Because if you can see right now, when we plug it in, and my LED is on backwards, as usual, the LED lights up because 5 volts are always present at the 5-volt pin. But this is not what we want. So this cable coming from the 5-volt pin always carries 5 volts in relation to 0 volts, which is ground. What we want to do is take our LED cable and bring in power from a different pin, one that is not always on, which means that we can send a higher low whenever we want. So that's what we're going to do this time by actually learning how to program the chip. So let's unplug all this stuff, get all of this out of the way, and we are actually going to learn how to program, and it's not that hard. Okay, so what we're going to do is we're going to connect our board to the USB port to our computer. We're going to open up the IDE software, write a program, and that program is going to tell the board to send power only to pin 2. Now, talking about voltage, there was something that we left out last time, which was this resistor value. As you recall, the relationship between voltage, as stated by Ohm's law, is it is equal to the current times the resistance. So how do we know what kind of resistor, what size resistor to use in this circuit so that we don't blow out our LED? Well, simple. Let's replace the values. So 5 volts divided by 220 ohms actually gives us 20 milliamps. And that is the maximum current that an LED such as this one is actually able to withstand. So we need to make sure that whatever comes through this power cable is no bigger than 20 milliamps. All right, and this is that calculation. We know that it will not be bigger than 20 milliamps because we are using a 220 ohm resistor for this LED. Okay, values are different depending on the component you're trying to protect, and you need to do that math whenever that comes up. And we'll look at some examples of analyzing circuits later on. But for now, suffice it to say that the 220 ohm resistor more or less is what protects this LED from receiving no more than 20 milliamps of current whenever we power it from a 5-volt source, such as this one. Okay, so all right, perfect. We know a little bit about the technical details about the circuit. Let's plug this back in and let's go back to powering the circuit from a pin that is controlled by us in code. So let's go to the computer. All right. Okay, so here is our new file in the Arduino IDE. And if you want to see how to download it, I left the link in the description. So as you can see, there are two functions, the setup and the loop. And the setup runs only once at the beginning, and the loop runs continuously, forever, infinitely. Okay, so the first thing we're going to do is to learn about the serial command. The Serial.begin is the function used to start the serial port so we can read and write to it. And println is what we use to print something onto the serial monitor, in this case, OK. So Now, when the program starts, we will actually see the word OK printed on the serial monitor. And then the only thing we're going to do in the loop function is digitalWrite. This command must be told the pin that it's going to write to, which in this case is the lead pin, and the command, which is high. Okay, so we're going to send the high command to pin number 2. And we're ready. So let's go ahead and select the correct board and the correct port from our tools menu. So let's move over to our tools menu. Okay, so we are going to pick the correct board, the Arduino Uno, and the correct port, which is going to show up as your USB port as soon as you plug in your board with the USB cable. And once we've done that, go ahead and click on the upload arrow button, and that will load the program. Okay, so as soon as we run this or upload it onto our board, the LED lights on the board blink a few times while data is being uploaded through the serial port to the chip, and then the LED is already lit up. It lights up almost immediately. So the current is running from the 2-pin through the LED back to the resistor to the 0 volt or ground reference. Well, so that was so quick. So let's see if we can actually slow that down by using the delay command. Okay, so to add the delay, we simply go over to the setup function and we add delay parentheses 5000. So what this is going to do is delay the program execution for 5000 milliseconds or 5 seconds. So let's go ahead and click upload. Okay, and here it is. It blinks when it uploads the data, and then 1, 2, 3, 4, 5 seconds, and it turns on. So there's our delay function. Alright, that's pretty cool. Okay, so what other cool stuff can we do? Well, let's try to make the light blink, for example. So what we're going to have to do is turn it on and off several times. And we know that the loop function is a sequence that basically repeats forever. So that's perfect. We just have to add on and off commands. Okay, so what we have to do is basically digitalWrite high, and then wait for 5 seconds, and then digitalWrite low, and wait for another 5 seconds. And that's it, because the loop function will keep repeating that high and low with a 5-second interval forever until we unplug the Arduino. Okay, so let's go ahead and do that. And here's the code. So let's just upload it. And there it is. Okay, so here it is. And as you can see, it's on for 5 seconds. Off, 1, 2, 3, 4, 5. On, 1, 2, 3, 4, 5. Off. And it keeps going. Okay, so it's doing exactly what we programmed it to do. And it'll keep doing that because the loop function keeps going on infinitely. Well, or until the microcontroller is unplugged from the power. Alright, so let's see what else we can do. Okay, so this works great. Now let's look at this guy. This here is a PIR sensor, and it detects infrared radiation right through this dome here. So basically, any object that moves in front of it will set it off, because every object emits infrared radiation. So let's look at how many pins it has. How many do you think it has? Yep, there you are, 3 pins. And it's very much like our potentiometer. 1 ground, 1 5 volt, and 1 signal. And that's actually why I have these colored cables on it. So the 5 volt red, the ground black, and the yellow cable is the signal cable. So any disturbance in infrared radiation from an object running in front of it will cause a variation in the voltage between 0 and 5. And that will basically put out a signal through this signal pin through our yellow jumper cable. And this cable is the one that we're going to plug in to our Arduino probably over here, maybe around pin 3. And whatever signal voltage we get out of pin 3, we're going to read it. And we might program the chip to do something like, okay, if there's a signal on this pin, then turn the LED on. If there is no signal on the pin, then leave it off. And that's basically what we're going to do to program this chip. So let's go ahead and plug in the 5-volt and the ground right over here on our power rails, as we discussed. Right there, 5 volts, keeping things neat, and 0 volts, or reference. Oops, there we go. Okay, and there we go. So we're going to do one more thing. We need to actually bring 5 volts from our 5-volt rail to the 5 volts on the board, because we need the board to output 5 volts here so that the PIR sensor will receive 5 volts. And all we need to do now is plug in the signal jumper cable into pin 3. Just like that. And now let's move over to our IDE and write the program. Okay, so here is what the code looks like. As you can see, we've added quite a few lines, but let's go through them. So we've added a peer pin variable, which is equal to number 3, because that's the pin we're going to connect the PIR signal cable to. And we've added a pin state and a val variable. These are going to be used for keeping the state of our peer pin. So when we start, we want the pin to be in state low and the val to be in 0. And we'll see why in a little bit. Let's jump over to the loop function, and here the first line is actually reading the peer pin variable, which is pin number 3. So we read it using digital read, and we store its value into the variable called val, which, as you recall, was initiated in the state equal to 0. And then we're going to evaluate what the value of val actually is. And if it is high, we are going to do something else. If it is low on line 20, we are going to actually do something else. Now let's dive into these two branches of the if-else statement. Okay, so we're going to be checking the state of the peer pin, and depending on if the peer pin is high, it means there was movement in front of it. So we are going to set the LED pin to high as well so that we can light up the LED. Else, line 20, if the value of the peer pin is low, then we are going to write low to the LED pin as well, which means that if there is no movement in front of the peer sensor, then we don't want the LED to be on either. And the only thing that might be confusing is the pin state. Now the pin state, all it does is it keeps track of the state of the LED. And it started out as low, because that's how we initialized it in line 3. But then as soon as we set it to high, by digital writing high on line 16, because it was low, we set it to high. And in the else branch, we do the opposite. We assume that the pin state is obviously high, so we set it to low. And that's just for keeping track of the pin state. All right, so if you ever upload a program to the controller board and you get this, so this is an error. The error is highlighted on the line, but it is also detailed at the bottom in the black window below and tells you what the error is. In this case, it's a matter of a missing curly bracket, and it has to do with my nesting of the if-else statements. So I'm going to check it, find the missing or extra curly bracket, but in this case I believe it says missing. And okay, so there it is. I was missing a couple of curly brackets, and now the code is fixed and it compiles and everything is working fine. Alright, so let's go ahead and upload it. Okay guys, don't forget that the board will only show up in the Tools menu until such time your board is actually plugged into your computer through the USB port. Otherwise, it won't show up if you try to upload, and it'll give you an upload error. Okay, so now that our coding is done and it's corrected, let's see what it looks like. All right, so here it is. And we pass the hand in front of the PIR sensor, and the LED lights up. You let it be for a while, it goes back off. And there is a re-triggering factor there. You need to wait a few seconds before it can trigger again, and there it is. It works again. Perfect, so we created a motion sensor that turns on an LED, which can be used for a whole bunch of applications and products like a night illuminator or something. All right, so this is basically what we are doing. We are taking data from sensors, we are feeding them into a brain, which in this case is our microcontroller. And the microcontroller will run through some code in much the same way as your brain does. And it'll spit out actions such as lighting a LED, playing a sound, or opening or closing a valve to let water through. Who knows? The possibilities are endless, and this is where the creation of new products really begins. Once you understand the basics, you learn a little bit about the different components that are available, and it's up to you to create a project. Alright, so I hope you enjoyed the video, and don't forget to like, share, and subscribe. See you all in the next video, and keep building.